So like I explained earlier, right, like we are trying to, like, there is an array of numbers. Each one represents the length of, or the height of the line at that particular index. So I need to get the biggest area, or like the area that can contain more water, right? So what I'm going to do is I'm going to start at 0 and try to get the height of each subsequent line in a hash map, right? And then when I go to index 1, I just need to multiply the current number, or like min between the current number and the subsequent number in the hash map, with -1 distance, right? So the hash map has the key as the index and the height of the line as the value, right? So when we are at index 0, let's say the height is 1, and you have a hash map of 10 numbers at 1, 0, 1, 2, 3, until 9. So when you're at index 0, you calculate the product of min of line at 0 and min of line at 0 and min of line at 0 and 1 into distance 1. And the same goes when you have 0 and 2. When you calculate the product of min of 0 and lines 0 and 2 into 2. So when you are incrementing to the next index, when you're calculating the area with the index 1 and the rest of them, you multiply with -1. You can use the same hash map, but for the indexes you can reduce the key by 1 when you are multiplying or calculating the area at that particular index with another line at another index. So you can keep on doing this, but it's still n square, right? I can probably try to implement an n square solution here, but the best possible way might be to, I'm trying to think what can be a good way. So basically it's not about the maximum line, right? When you are at a certain index, you can go through all the indexes. It's not about the biggest index. It's about the product of index and the distance between the two lines. Product of the height of line at index and the distance between the two lines. I think one way that you can improve is actually when you're at index 1, you can ignore, when you go from 1 to n, right? So what I'm trying to get at here is, like, you have this example where at one index you have height 8, and at the 7th index you have height 7. So min of both is 7, and the difference, or like distance between these two lines is 7. 7 into 7, it's 49, right? When you go to the second index, there are no chances of this being creating a more area with the last line. This line is smaller than 8, which is 6. So when we are incrementing the index, if it is smaller than the min, so let's do an n-square solution, right? Like what I can do is create a hash map integer integer h1 is equal to new hash map. So this hash map would hold the index to line height. It will hold index to line height mapping. So I can just go from int I is equal to 0, I less than height dot length I plus plus. So I can go through each index and add it to the map, right? If so, at the end of it, I have a map of indexes and height. So I can start with index. So now what I'll do is so whenever I'm at index 0, I'm going to get the length of the line at index 1, 2, 3, 4, 5 subsequently and calculate the minimum value. So let's say int max area is equal to 0. Let's start with 0. Int current area is the buffer area which we are covering the max with. So the current area for the first iteration, let's say, right? So should always be I plus 1. Current area is equal to j minus I into math.min of height I comma height j. We calculate this, and if it is current area is greater than max area, then max area is equal to current area. Once this is done, we return max area, right? And we can test this for this input, and it should work. It should not cause an issue. So for this one, see, it didn't cause an issue. But if it is 10,000, it's if it is 10,000, I'm not sure if it will work. I'm just trying to copy these, right? And let's just try to see for a big number what the performance turns out to be. It's 8 millisecond, so it will just scale up. I'm sure it will scale up. So this is a very big number. So as long as the numbers are increasing, it's just blowing up. The time taken for it is blowing up, right? Let's submit it and see. Time limit. Oh, it got accepted. N-square solution is fine for them, but I need to do better, right? Better would be, how can I do better? I'm not sure how we can do better, but one way would be so it's a product of the distance and the min height between the lines, right? Instead of 7 into 7, it will be 6 into 7. It's a math way of solving things, right? Like, I think there should be some math problem or math way of doing this. I'm really not sure. How would we do it? Let's say we are starting at index 0 and we calculate all the areas. How can I use that information for the second index? If I'm able to do that, maybe we can reduce the time taken for the program. So when we go from first to second index, is there a way that we can add the difference of the areas? So between 0 and 2, the area was min into 1, right? The distance is reduced is something that we know. Yeah, so I think when you are calculating with 0 and the other indexes, calculate the areas, and when you go to the second index, calculate with the third and fourth and fifth. the only way can be bigger is if the height is bigger than the min. The min height between z1 and 2 is bigger than index 0 and